Alright, this is our industrial simulation final project. My name is Chase Brown.
I'm Eddie Genovese.
I'm Mackenzie Suderman.
And I'm Jacob Kraus. For our introduction of our project that we were doing, we had two scenarios in which Asia is shipping directly to 6 different distribution centers. And then the second scenario is where Asia is shipping to a regional distribution center in either Panama or Miami, and then goes directly to the 6 countries for their distribution. So there are shipping cases of items, we don't know what, that have different daily demands depending upon the country. Shipping can only happen once every week to each country respectively, so we did account for that. And it can only be shipped by the thousands of cases in TEUs. And then also at the end of the model, we were trying to figure out the most profitable business plan. So we do financial costs for operating, shipping, ordering costs, and along those lines, we also had to do manufacturing costs. But as a team, we figured out how to do all of that.
All right, so this is what our model looks like for the first scenario when Asia ships directly to all of the facilities in the Caribbean, Central America, and South America. So Asia ships over materials and it goes directly to any of the specific distribution centers. So what that looks like when it's not all animated, you can see our source of Asia has time packs connected to servers for each of our different facilities where we sell material out of. And we ship an order every time. We're not shipping actual units. So every time an order comes down one of these time packs, it's going to be a group of however many they're shipping at a time. And that's what we got for the modeling details on scenario 1.
So while that was what was happening within the model, we had a lot of things going on in the background through processes and other modeling tools for all the other portions of our operation. So just to run those down, we use material elements for all of our inventories for each of our respective facilities. Monitor elements kept track of when we would reorder and how we can keep track of those inventory quantities as they're going up and down. State statistics, we use those for lost sales monitoring. It's just a very easy process we'll show here in a minute. And the timers were actually a really big part of our operation as it helped us reset the demand every 24 hours as well as show how often sales were coming in. So it kind of helped us track our demand. A few other quick things we use, just of course, real properties for our reorder point, reorder amounts. We easily plug it into an experiment for optimization, as we'll talk about in a little bit. And real estate variables just for a couple things to help us with some routing logic throughout the whole process. So these are some of our processes we use. Each of these were kind of multiplied for each of our locations, but these are some cutout examples where we can talk through it. Process 1 up here was how we went through the process of reordering for each of our locations. So we kind of decided, one, is my inventory low enough at this location that I need to reorder, then decided that it was worth sending to that location rather than other locations in its region. It assigned a couple state variables that helped us track the order, fired an event that sent out the model entity, delayed, and then came through to produce more units. That's what really sent out that model entity and started on that time path. Process 2 here, this is just for our demand reset. So we had a constraint under the model that every day our demand resets to a random distribution. So every 24 hours a timer would go off to start this process, and this process would just go and reset basically our demand that other timers would use to have our sales keep flowing in. Down here, it kind of process 3 flows right through process 2 to where this is every time a sale happens. So all those other timers that are saying at each of our locations sales are happening. Whenever it happens, it decides, do we have inventory in stock? If it does, then we lose one of our inventories and have a sale. If we don't, then we add one to our lost sales count so we know we're losing that prospective sale. And our final process down here, second. is just when we reach the end of our time path. Very simple. This is when our order reaches any of our prospective places. What it was it would have a delay for the unpacking of the shipment and then adding the quantity of that shipment into our order amount. So we have the inventory to account for it.
Alright, so we're having a little bit of technical difficulties, but
There we go.
here's our next scenario modeled. Everything's almost exactly the same, except in this scenario where you're first shipping our goods from Asia to a local distribution center, in this case it's Panama. So pretty much we added a new time path that ships to Panama, and that server will have 5 time paths connected to its output going to each of the other facilities where we're selling our goods out of. Okay.
So then, once our models were set up, we wanted to put them into an experiment to see which one gave us the highest profit. So to do this, we used the OpQuest experiment, and we set up the reorder points and the reorder amounts as the controls. And you can see that the reorder amounts are in intervals of 1,000, that was specified in the problem. And then our responses were gonna be the different costs that we had, so that was holding costs, manufacturing costs, processing costs, and transportation costs, and then our sales. And then we combined all of our costs and subtracted these from our sales to get our profit, which is what we wanted to maximize. And then when we ran our experiment, we wanted, like I said, to maximize profit, and we ran 300 scenarios to give us the best case scenario for our reorder point and our reorder amount for each. So within our model, we kind of tried the continuous and also the periodic reorder strategy, and we realized that continuous was just gonna be a lot better for our profits rather than reorder. So that's what we ran our experiment with, was the continuous reorder strategy. And so for scenario 1, shipping directly from Asia, these are the results we got for each of our reorder points and reorder amounts. And you can see there that we got a profit of 3.34 billion CRC. For the second scenario, when we had our distribution in Panama, these are our results for the controls, and then our profit for that one was 2.27 billion CRC. And then for the other, for the Miami distribution center for scenario 2, these were our controls for that one, and then this one yielded a profit of 2.41 billion CRC. So based on our results, we recommend using Asia to ship directly to each local distribution center because it yields the highest profit. So that concludes our presentation.